Well, next is list rendering. v-for. We can use the v-for directive to render a list of items based on an array. The v-for directive requires a special syntax in the form of item in items, where items is a source data array and item is an alias for the array item being iterated on. So if items is an array, a reactive reference, which is an array, which contains two objects, which with keys message with value foo and message bar, then we can iterate over these array items with this v-for equals double quote item in items. And let's actually take a look at what it does. It's basically gonna look at these items. It's gonna see, okay, this items is an array. It has number of elements. Let's iterate over the array and assign and grab each item from items and then render this with each of them. List element with a message content. So let's just take a look at how this works. Let's get rid of this. Let's get rid of this, and then let's go here and let's make these things right. Let's grab it inside an order list, and then let's print the list of items. And formatting is terrible. Okay, this is a bit better, like that. So we have this items ref with these two items, and by virtue of this v-for, we are rendering two list elements with text content, this thing, the message inside the items. It's pretty easy. I mean, no problem here. Inside the v-for scope, template expressions have access to all parent scope properties. In addition, v-for also supports an optional second alias for the index of the current item. Yeah, so we have a parent message in the parent scope. We have access to this inside, and we can also access the index of the array like this. Wrapping in parentheses, then the first element is the item itself, and the second element is the index. So this is going to render the parent, then the index, and then the item message, these two guys inside. The variable scoping for v-for is similar to the following JavaScript. Const parent message equal parent, const items is an array, and items dot for each, item index. Yeah, so it's essentially telling us this scoping for the view template is analogous to the scoping of the for each method of an array. Notice how the v-for value matches the function signature of the for each callback. In fact, you can use the structuring on the v-for item alias similar to the structuring function arguments. So we can do that. True. Because the items have a key message inside, we can destructure that as an object like this, and then we can directly access the message. And with index alias, we can do this as expected. So we can here, if we want message, we can add two properties, name John. Let's make it single quotes just to be consistent. Name Garfield. Never mind the spacing. Doesn't matter the spacing. Instead of getting the item directly, we can destructure this thing like this. Message name, and then we can print them directly. Message name, like that. Exactly. For nested v-for, scoping also works similar to nested functions. Each v-for scope has access to parent scopes. So we have a list item, v-for item in items, and then we have a child inside, span with another nested loop inside, v-for child item in item.children. So we have access to the properties of the element in the outer loop, like this item message, and then we also have access obviously to the properties in the nested loop, like this. You can also use of as a delimiter instead of in, so that it's closer to JavaScript's syntax for iterators. Okay, all right. So I can actually do this. I didn't know this thing. So that's the same. All right. v-for with an object. You can also use v-for to iterate through the properties of an object. We have an object, a reactive object with some properties, and then we have an unordered list of items. And here we have the v-for, which iterates over the properties of the object. My object iterates over the value, and then the value is, I guess, these items here. You can also provide a second alias for the property's name, aka key. There you go. Yeah, you can do that. And another for the index, value key index in my object. And if you are wondering how this thing looks, we have here import reactive, then we have our reactive object, and we have our loop with value key and index. And in here we are printing them as index key value. So you have the index, because object keys also have an index, then the key, and then the value of the key. As you can see, this is the key, this is the value, and the same for the rest. We can close this thing, we don't care. Yeah, and then note, when iterating over an object, the order is based on the enumeration order of object.keys, which isn't guaranteed to be consistent across JavaScript engine implementations. Yeah, that's good to keep in mind, but at least in my mind, I always tend to associate order to arrays. So if we have a list of items where the order matters, then the logical thing to use is an array. If we have a group of items or properties where the order doesn't matter, they are just attributes of something without, like, where the order is meaningless, then an object is more appropriate. So if order is important in any way, you should use an array anyways. v-for with a range. v-for can also take an integer. In this case, it will repeat the template many times based on a range of 1 to n. We have a span with a v-for n in 10, which prints n. Here, note here, n starts with an initial value of 1 instead of 0. So this thing here is going to create 10 spans with content 1 to 10. You want to see it in action? We can. Just like that. There you go. Starting with 1, as it says, and then ending with 10. We could also add a comma to see it better. There you go. v-for on template. Similar to template v-if, you can also use a template tag with v-for to render a block of multiple elements. For example, if we have a number of list items, we can grab them in a template and use the v-for in the template. v-for with v-if. It is not recommended to use vif and v4 on the same element due to implicit precedence. Refer to style guide for details. When they exist on the same node, vif has a higher priority than v4. That means the vif condition will not have access to variables from the scope of v4. This will throw an error because property todo is not defined on the instance. So list item v4 todo in todos. If we try to access this element of the loop in the vif, this will error out. This can be fixed by moving v4 to a wrapping template tag, which is also more explicit. That makes perfect sense. Of course, there is a better way to do that. That is iterating over the already filtered to-do items. So already iterate over the to-dos that are not complete. So yeah, let's grab this thing for a second. Let's put it here so that you see what I mean. We have this thing. This breaks because to-dos doesn't even exist now. If we have a reactive, then we do a const to-dos is equal to reactive. Let's make it a ref because for some reason they use ref with arrays. Let's make it an array of to-dos, and the to-do is name to-do 1 and is complete true. And let's copy this a bunch of times. If I can copy this thing because okay, that's this. Let's add 4 to-dos. 3, 4, and let's say to-do 2 and 4 are not complete. So here it's complaining that cannot read properties of undefined because this is not defined here. So what the documentation is suggesting us is if we want to use this pattern, we can wrap the list item in a template and use the loop in the template like this. Template, then grab this thing, put it here, and then grab this template and wrap it here like this. Okay. So now we have only the to-dos which are not completed, as you can see by this thing. But we can also do something like this. We can create a computed property, const to-dos, let's call it for what it is. Not completed to-dos is a computed which returns our to-dos. We need to access them with value, and then we need to filter only the to-do which is not complete. And then we can use this thing in the loop. Like, let's copy this thing again. Let's paste it here. This is gonna break because of this, but let's get rid of this. And then instead of looping over to-dos, we loop over not completed to-dos. There you go. That's a better option in my opinion. Create a computed property which filters out the things that we want to display and use that in the loop. Managing state with key. When Vue is updating a list of elements rendered with v4, by default it uses an in-place patch strategy. If the order of the data items has changed, instead of moving the DOM elements to match the order of the items, View will patch each element in place and make sure it reflects what should be rendered at that particular index. This default mode is efficient, but only suitable when your list render output does not rely on child component state or temporary DOM state. For example, form input values. To give View a hint so that it can track each node identity and thus reuse and reorder existing elements, you need to provide a unique key attribute for each item. Well, you give a key to each item like this. You give it some unique key inside the loop items. So if we have a loop, the value of this key should be unique to each item in the loop. When using template before, the key should be placed on the template container, like this. The key should always be placed, I think, on the element that contains the loop. And this is basically a way to add a tag to the loop elements. Maybe you have to reread this thing, but I think it's kind of to prevent View from confusing which element is which element. As it says here, the default mode is efficient without the key, but only suitable when your list render output does not rely on child component state or temporary DOM state. I don't fully get it, but let's move forward. Note, key here is a special attribute being bound with vbind. It should not be confused with the property key variable when using v-for with an object. Sure. It is recommended to provide a key attribute with v-for whenever possible, unless the iterated DOM content is simple. For example, it contains no components or stateful DOM elements. Or you are intentionally relying on the default behavior for performance gains. Okay, so we need to use key if the loop items are components or have a state. So I'm gonna grab this thing. In loops, usually use key. We need key if the loop contains components that are stateful DOM elements. If it's just a static list of things, then we don't need it, basically. For example, to think of a DOM example, if we had something like v4 n in 10, and then inside the li we just have hello, then we don't need any key here because there's nothing stateful here. v4 with a component. Wait, the key binding expects primitive values. Strings, numbers. Do not use objects as v4 keys. For detailed usage of the key attribute, please see the key API documentation. v4 with a component. This section assumes knowledge of components. Feel free to skip it. You can directly use v4 on a component like any normal element. Don't forget to provide a key. My component v4 item in items, and then the key. However, this won't automatically pass any data to the component because components have isolated scopes of their own. In order to pass the iterated data into the component, we should also use props. We didn't see what props are yet, but it's a way to pass data into a component. We have my component, we have the loop as before, we have the key as before, and then we pass these two props, which are the item and the index. The reason for not automatically injecting item into the component is because that makes the component tightly coupled to how v-for works. Being explicit about where its data comes from makes the component reusable in other situations. Check out this example of a simple to-do list to see how to render a list of components using v-for passing different data to each instance. Okay, so we have to-do item, which defines two props, title and remove, which are used in the template. Title is a string, probably, and remove is a oh no, the remove is not a prop, it's an emit. The only prop is title. To-do item takes that title prop, all right. And then in the app, we have some to-dos, some state defined, some function add new to-do, and then we have a form with a label, with an input, with a button, and with a list of items, with a list of to-do items, where we use the to-do item component directly with a loop, which loops over the to-dos, these guys over here, and uses the to-do and the index. And then we have the key, and then we have the title, which is the prop, which passes in the title of the to-do we are looping over. And then it adds some listener, which we don't care about. So the title, for example, do the dishes, shows up here, and this value is what is rendered by this element right here. So that's how it is. We pass in the to-do item, we pass in the title as a prop, like this. We bind the title property, the title attribute to the to-do title, and in the to-do item, we define a prop title like this. So far, so good. Array change detection. Mutation methods. View grabs and observed arrays mutation methods, so they will also trigger view updates. The grab methods are push, pop, shift, unshift, splice, sort, and reverse. Replacing an array. Mutation methods, as the name suggests, mutate the original array they are called on. In comparison, there are also non-mutating methods, filter, concat, slice, which do not mutate the original array but always return a new array. When working with non-mutating methods, we should replace the old array with a new one. Here we have an item which is a ref with an array value. Items.value is equal to items.value.filter, and then whatever filter we want to apply. So we need to reassign. That's more JavaScript than Vue. Basically, we have some array methods mutate the array, which means that we don't have to reassign the array value. Some other array methods do not mutate the array, but return a new array. And in this case, we may want to reassign this value like that. You might think this will cause Vue to throw away the existing DOM and re-render the entire list. Luckily, that's not the case. Vue implements some smart heuristics to maximize DOM element reuse. So replacing an array with another array containing overlapping objects is a very efficient operation. It's very nice. I'm going to add it to my notes. Displaying filtered sorted results. Sometimes we want to display a filtered or sorted version of an array without actually mutating or resetting the original data. In this case, you can create a computed property that returns the filtered or sorted array. For example, Const numbers is a ref of an array of items, and then we have const even numbers, which is a computer which filters the values from this array. And then we have a list item which loops over the even numbers. This is similar to what I did a while before. In situations where computed properties are not feasible, for example, inside nested before loops, you can use a method. Constant sets, we have two nested arrays. Inside an array, we have a function even numbers, which takes an array of numbers and filters out the even ones. Then we have two nested loops. Before numbers in sets, so it will loop over the outer array, which has two elements, these two arrays. And the inner array will take these numbers with this method, and then will loop over the filtered out inner arrays. The reason why we cannot use a computed property here is because we need to know over which of these arrays we are looping. Be careful with reverse and sort in a computed property. These two methods will mutate the original array, which should be avoided in computed getters. Create a copy of the original array before calling these methods. Sure. Array methods that mutate the array should be used with care, that's for sure. If you want to prevent mutating the original array, you can destructure the array like that. This is basic JavaScript, nothing new here. So next is going to be event handling.